Hi everyone, welcome back to another SimplePlanes video. In this video, I'm going to be coding the SWL-120's engines. So, let's get started. In case you haven't seen my previous video, I explained how this engine uses exported and imported parts as mod parts to have a 2000 part equivalent engine be approximately 50 parts, because the airflow guides can't be mods, but basically 2000 parts into 4 parts with rotators added. So, as I mentioned, we're going to be coding these engines. This is not going to be a tutorial, it's going to be me coding them, but I'm going to explain how this works, so you might learn something even though it's not explicitly a tutorial. Before I can start coding, we have to understand exactly what we want the engine to do. A typical turbofan jet engine, which this engine is, has two main stages, or two separate parts that spin, the N1 stage and the N2 stage. The N1 stage includes the front fan, the low pressure compressor, and the low pressure turbine. And the N2 stage, which is in the core of the engine, includes the high pressure compressor and the high pressure turbine. In between the high pressure compressor and the high pressure turbine is the combustion chamber, in which fuel is mixed into the engine air and ignited. This provides thrust, and in older engines, which are called turbojets, this would produce 100% of the thrust. However, in modern turbofan engines, which are more efficient, this provides a very small amount of thrust, and then this drives the N2 stage, which provides most of the thrust coming from the front fan. Now I know exactly what we're going to be coding around, the N2 and the N1 stages. So first we're going to add some variables for this. So this is the engine to reverse thrust, that's not really what we want. And this is from the original engine, which I'm just going to keep here for reference. So we're going to have engine 2, N1, and N2. By core, this is just a way for me to identify my own variables. This is the variable that's going to be used by the engine rotator for the N2 and N1. I have some placeholder code just so I could test some stuff. We're going to change this in a bit. The N1 and the N2 core, I'm just going to put the same code in. I want this engine to be realistic in that you don't just click a button and it turns on, or you don't just turn it on with throttle. For example, the game's basic engines, you control them just with throttle by default. So they're apparently idle even though they're actually not spinning. And then when you apply throttle, they just instantly turn on. I want to have to apply pneumatic air to start the engine, or a way to spin it up. When N2 is above a certain percentage, then I can input fuel and then the engine will start. If I input fuel and the engine is below, and the N2, not the engine, is below a certain percentage, then I'm not sure what I'm going to do, but either the fuel does not be inputted, which is what the old engine has, or there'll be a simulated hot start, which is a real thing, and it's when basically a fireball comes out of the engine. It doesn't really damage the engine, but it's not really a good thing either. So we're going to add a few different behaviors to the engine. I'm trying to explain this in a way that makes sense, probably not going to make sense though. I'm going to start with just applying pneumatic air to start the engine, or really spin it up. The N1, which includes the N1 fan and the low pressure compressor and turbine, is going to basically be dependent on what N2 is doing. So we're going to start with N2. I'm also going to quickly show you the details of this engine. So this engine is an SWL X series engine, which is a fictional engine. It is based on the GE90, which is a real engine, and is used on the 777. The SWL-120 is also based off the 777, really the 787, but it's similar to those two planes, and so its engines, which also gives us some real-life values. We want the N1 and N2 speeds to be similar to the GE90's real-life speeds and RPMs. And what I found is that max RPM, the GE90's N1 stage, rotates at approximately 2,500 RPM. Now I've done some simple math, and I've determined 2,500 RPM approximately comes down to a speed of 50. So let's say we have a bunch of code that outputs 1 when full throttle is applied to the engine variable. We want to times this code by 50 to get an equivalent speed in-game of 2,500 RPM for N1. N2 spins at over 10,000 RPM, so we want to have a multiplier which I haven't calculated yet to do that. The code from earlier, 50 times throttle, gets us that speed, so if I put full throttle here, this, even though I can't really see it, is what 2,500 RPM looks like, or approximately that, in SimplePlanes. And actually the original engines, even though I wasn't even looking at the GE90 for that, do spin at exactly that same speed, although it's a little different, but they mostly spin at that speed, 550 something. So there's that, there's also reverse thrust. I'm going to have to code that behavior in as well, but the actual details of reverse thrust include this cowling sliding back, revealing these other details. And also there's these airflow guide things, there's a name for them, I'll probably put it up on screen. And these things I can't export because they're one part, and there's also 24 of them plus rotators, so there's 48, yeah it's 48 parts as well, so I can't actually get that down, but it's better than 2,000. Or 200 in the case of the original engine. Before I go any further, I'm also going to cut the cowling in half so we can see the inside of the core. This is pretty simple in Unity. I have a separate model which is half the cowling instead of a full cowling. I designed it for exactly this purpose, which is to cut the engine in half in game. So I'm just going to re-export the mod, and then we'll have half an engine. So now the engine is cut in half, we can actually start coding it. We're going to start with the N2 core. I'm going to make it spin up when our engine dial, in this case set of buttons instead of an actual dial, it'll be the dial on the actual plane, is set to start or setting 2. This simulates providing pneumatic air to the engine. The variable engine2 N2 core is the one which is used in the rotators which rotate the N2 physical 3D model. So we're going to add the code, clamper 1, engine2 dial equals 2. This returns 1 when the engine2 dial is setting 2, and 0 when it's not. We're also going to smooth this, and I'm going to start with a value of, I don't know, 1. And before we go any further, I'm also going to add another variable. I'm going to call this engine2 N2 target. Now this is going to become a key variable for what I call a double smooth, which is where you have a smooth sim code, a number, and then that number is also smoothed. It's a little bit complicated to explain, but in the form of this graph, which I should hopefully have up on screen, you can see how the smoothing works with a normal smooth versus a double smooth. The engine2 N2 target, I'm just going to swap these, is going to be used in the N2 core to simplify the code. The smooth engine2 N2 target, I'm just going to put 0.1 for a placeholder, and the N2 target is going to have all of the code which actually drives the core, I think. Now I'm going to add some other variables. Engine2 N2, I'm just going to, all these are going to be engine2 N2 something. This one's going to be resistance, so engine2 N2 resistance. This is going to be how much the N2 wants to stop spinning. And another one's going to be engine2 N2 force. This is going to be how much the engine wants to start spinning, or keep spinning, or increase its speed or something. I'm going to have the engine2 resistance value be a function of the overall speed or RPM of N2. I guess that'll be the engine N2 core value, which basically means this is going to be just engine N2 core times, I'm just going to say 0.1 for now. I wonder how different this is going to turn out compared to my expectations of this. What I'm going to do is I'm going to go off and try some things, and then I'll show the results later.
Many minutes later.
So these are the 3 variables I've come up with: engine N2 target, engine N2 core, and engine N2 air effect. N2 core and N2 target are the main variables, engine N2 core being of course the main variable which is used for things like the engine information display and the actual N2 3D model which is in the engine. N2 target is useful for a double smoothing effect, and engine N2 air effect is one of several to be added variables which are inputs to the engine, air effect being the air starter. To get a double smooth, I first have, let's take air effect, which is the only current variable I have which is an input. Engine N2 target is just engine N2 air effect, and the reason I have one variable just using another variable is because this will eventually be multiple variables for the input. Engine N2 core has the same effect, this time it's in a double smooth. To get a double smooth, I subtract the core, really the current value, from the target value. This gets a larger value the further we are away from the target, and a smaller one the closer we are to the target. I then use the absolute function around that subtraction, because if, let's say, the engine N2 core is actually above the target, this will return a negative value, and the absolute makes sure it's always a positive value. So even if the subtraction returned, say, negative 0.5, the absolute function would make this into 0.5. I then clamp it between 0.05 and 1. Those might change later, to ensure we are always changing our speed, because if I didn't have this clamp, the closer we got to the target, the smooth would just go down slower and slower. So that is how the double smooth works. The code for the air starter starts with the engine 2 dial. First, to make sure this is 2, then I clamp it to get 0 or 1. Then times that by 12, because 12 is the equivalent of 24% N2, which is what I believe to be the maximum value of the air starter. Or if it isn't, it's close enough. And I times this by a clamper 1, which makes sure the N2 core is less than 12 or equals to 12. This is for a future bit of code I might add, which brings back the resistance variable, which will allow me to have a higher resistance the higher the N2 is, going down to 0 when we start to approach 0 and 2. Then smooth it all by 0.8, just so it smoothly increases, not just jumps to 1. Let's see how it runs in game. Pay attention to these variables up here. I'm just going to click the engine 2 dial number 2 button. So we can see this is starting to increase to 12%, really 24% and 2. And note the behavior as it approaches 12. I'm not sure if it's too obvious, but as it approaches 12, it slowly decreased its rate of increase. And then when I put this to 0, I have made the effect slowly go down that same smooth rate, 0.8. In real life, we just cut out supply completely. That would mess up my code, so I just made it slowly decrease. I think this is pretty good so far. Now I'm going to work on adding fuel input, which is going to take a little longer. So once again, I'll do that, and then I'll get back to you.
1 hour later.
I have now added the fuel effect. What the engine can do so far is be spun up to 24% N2. And then when N2 is anywhere above 22%, you can add fuel and the engine will start. The engine can now be brought up to idle by adding fuel. Idle is not yet added, however. I also redesigned the core N2 variable. Now instead of going to 50, which is the number which is used by N2, and actually that's the number for N1, the number for N2 should actually be 200, because 200 is times 60, 10,000, or I think it's around 10,000 OPM. Which is what N2 is in real life for the GE90. But I had it at 50, which is the equivalent of 2,500, which is for N1. So anyway, N1 and N2 in the variable setters are actually going to go from 0 to 100, which is a percentage. Well, it's not really a percentage, but the number's going to be from 0 to 100. And then we're going to add a simple multiplier in the rotators to get the true RPM. Just wanted to point that out. Because of this, I changed N2 effect from 12% to 24%. As well as anywhere else is referenced. In fuel effect, I've added some code for air effect, because when air effect is cut off, because air effect is actually going to drive some effects when I add some more effects like sound and things to the engine, that's going to have to be cut off at some point. If that were to happen, fuel effect would actually only get the engine to 46%, not 70%, which is what it does in real life. So what I did is I made it so when air effect is cut off, fuel effect instantly adds the same loss that air effect was providing. You'll be able to see this in the variables when I load the engine in the level. You may also notice two variables below all this. Engine 2, N2 combustion. That's there twice because it has a 1 and a 0. This has some activators. So N2 combustion is only on or active or when, whatever, when engine 2, N2 core is above 21% and engine 2 fuel is equal to 1 or on. It's also 0 when the N2 drops below 20%, or engine 2 fuel is 0. The reason I use activators and not just have it be 1 or 0 is because sometimes, let's say, is because it just sets it when these activators are true, and then it stays at that, even if these activators are false, yet the other activators are not activated yet. I mentioned this activated behavior in one of my variables tutorial videos, which will be linked in the video description. I've also redesigned the N2 target and N2 core. So since N2 target is just all of these different effects added together, I've used N2 target instead of these effects added together in N2 core just to slightly simplify the code. So let's see this in the level. I also added N1 to be just N2 but a quarter of the speed. That's not going to be the final behavior, it's just so I can see what it's like instead of having to like zoom in here or something. I'm also going to quickly add the variables again. So as I start the engine, air effect is slowly increasing to 24. The N2 target is exactly the same as air effect because it's just air effect that's working now. N2 core is slightly behind because of that double smoothing effect which I've explained already. I'm going to wait for it to go up to the full 24%. So watch what happens as I click the fuel switch. The fuel effect is now 46 instantly. And again, watch what happens when N2 core passes 50%. Air effect instantly goes down to 0, or at least very quickly goes down to 0, and fuel effect goes up to 70, and that's how I'm able to shift the air effect increase number, which is 24, from air effect to fuel effect. Now the engine is idling. N1 is spinning too fast for idle, that's because it's just based off the N2 variable. I'm going to write some code for N1 later. Now the behavior I'm going to add is making the engine respond to throttle. Once again I'll do that, and then I'll get back to you.
20 minutes later.
And that has been done. It was relatively simple compared to air effect and fuel effect. I just got the engine to throttle lever, which was another variable from up here. This was already there. And then I add engine to reverse, which is the reverse thrust lever, times by 0.7 because the reverse thrust does not reach full throttle. And then I just make sure the engine to N2 core is above 70% before the throttle can work, and also fuel effect has to be above 70, so that way the engine can't keep running after fuel is cut off. Then I smooth all that by 8. And that's pretty much it. Else times it by 30 to get the last 30% remaining of N2, 70% to 100%. And then I just add that in target. There's also another variable, engine2 on. The purpose of this variable is just to indicate the engine is on and idling. In the level, you can see how it responds to throttle. Adding full throttle takes it up to 100% N2, and that's really all there is to it. Reverse takes this up to 91% N2. And also something I almost forgot is I added some code to increase the upper limit of the double smooth in here, N2 core, when N2 core is above 70. Because when the N2 core is increasing to idle, it does this over a long amount of time, so it slowly increases the speed. But when it's idling and you add throttle, you want it to respond as fast as possible, and to make it realistic, I did that here. So it's either a smooth of 2 when it's below 70, and if it's above 70, then it's a smooth of 10, which was that speed that you saw in game. Now that's the maximum smooth. Since it's double smooth, this can also decrease to something like 0.05. And actually, I'm just going to increase this to 0.2, because I found 0.05 is just a little unrealistic, because it takes a while to smooth off. So I want it to be something faster, like actually 0.15. So now what I'm going to do is I'm actually going to go ahead and finish basically the entire engine. This will include things like having N1 respond to N2 by itself, not just run off the variable. Like idle, like N1 will idle at like 20%, and then it'll go up to 100% as throttle is added, which is different to N2. I'll also add another special feature for N1, which is to make it windmill when there's wind, or when let's say the engine is shut down when you're flying, which is again basically wind. It's just another realism effect. I'm also going to add a hot start feature, which is where if you add fuel before the engine is ready to start, it's a very simple variable. If N2 is less than 22% and fuel is on, then hot start is 1. I don't have to change any of my other variables like fuel effect, I just have a new variable. This will include some simple effects like flame, as I mentioned in the beginning of this video, where a fireball basically comes out of the engine. So I'm going to do all of that, and then I will show you the results. So it's sort of finished. The only thing it needs is just a little bit of tweaking with the smooths, the double smooths I mentioned earlier. Let's just go ahead and start it up. The N1 and all the variables are done. I just need to do a lot of trial and error with the smooths. I have some variables such as engine to fuel consumption, which is a variable which tells me how much the fuel the engine is consuming, which is useful for an engine display, and also calculating how much fuel is left in the wing tanks. So you can see here engine 2 core reached its max, and engine 1 took a little longer than it should have. When I add fuel, you can see it starts to increase. However, N1 core seems to take a little longer than it should, so I'll need to change that. So when I increase throttle to, I'm just going to hit it at max. You can see engine N2 core hit 100, except engine N1 core hit 100 before N2 did, which based on how this engine should work is actually impossible. But really it's just a bunch of trial and error with smoothing. So what I'll do is that'll be it for this video. In my next video, which should be coming out next week, I will show you this finished engine. It'll include features I haven't had the time for, such as the hot start effects like fireball coming out of the engine, and also the engine N1 windmilling behavior, which I haven't actually done. So I hope you enjoyed, make sure to like, comment, and subscribe, and I will see you in the next video. Bye!